We're going to look at the last two types of factoring today, and they're very similar. In fact, the AC method uses factoring by grouping. So let's take a look at a review of factoring by grouping. Typically, you'll have a quadnomial or 4 terms, and you split them into 2 terms and factor out the GCF. If what's left from each of those terms is the same, then you're factoring out that GCF again. For the AC method, the one additional step is you multiply the lead coefficient by the constant before you set up your t-chart. So 3 times -2 is -6, so we're finding the numbers that multiply to -6 and add to 5, which in this case would be -1 and 6. So we rewrite that middle term of 5x as a -1x plus a 6x, and then we can factor by grouping after that. So we've got our same essential question, how is factoring useful? We'll see this especially when we're solving equations. Factoring is an easy way to solve a quadratic typically, but there's other uses for factoring as well. So let's start with a review of our factoring by grouping. Again, we've got our quadnomial, so we'll split it into 2 and find the GCF for each piece. So for our first 2 terms, we've got a common factor of 2x squared. Dividing 2x squared out of each piece, we've got 4x cubed minus 3. For our second 2 terms, that 12x cubed minus 9, we've got a common factor of 3. Dividing each term by 3, we have 4x cubed minus 3. And again, we've got that common factor of the 4x cubed minus 3, so we're going to factor that out. What's left from our first term is the 2x squared. And what's left from our second term is a plus 3. We'll take a look at factoring by grouping again. This one, I notice we have a common factor of 2 in all of our terms, so I'm going to factor that 2 out before I start my grouping. Then we'll split our quadnomial into 2 pieces. The 2 on the outside are GCF. We can't lose that as we factor. With the factoring by grouping, we end up putting parentheses in. So I'm going to start with a bracket to differentiate that 2, which was the first GCF, from what we're doing next. Looking at the first 2 terms inside the parentheses, we've got a common factor of y squared. Dividing that out, we've got y minus 4. From the second set of parentheses, notice the second 2 terms are opposite signs from the first 2 terms. So I want to factor out a -2 on this one, leaving me with a positive y minus 4 so that my parentheses match one another. Continuing to factor that 2, which was our first GCF, we need to keep. The y minus 4 is our second GCF when we're looking inside the brackets. What's left is y squared minus 2. Looking at our AC method, again, we start by setting up a t-chart, but not with just the constant. We multiply that lead coefficient by the constant to figure out what we're multiplying to. So in this case, we're multiplying to a 6 and adding to a -5. The numbers that both multiply to a positive and add to a negative would be 2 negative numbers, and the -2 plus -3 will add to that -5. What we do with these, there's no shortcut on this one, so we're going to rewrite that middle term using those 2 numbers we found. So we start with 3y squared. -5y equals -2y minus 3y, and then we have our plus 2. Once we've rewritten our trinomial as a quadnomial, we can factor by grouping. So our first 2 terms have a common factor of y, leaving me with 3y minus 2. Same problem on this one. The next 2 terms have opposite signs, so I'm factoring out just a -1 in this case, leaving me with 3y minus 2. They've got that common factor of 3y minus 2, and I'm left with y from the first term and minus 1 from that second one. Looking at example B, the first thing that I want to do on this one is factor out the negative, because when you set up your AC method, it's much easier to work with if that lead coefficient is positive. Then we're going to set up our t-chart, figuring out what multiplies to, again, we're taking that lead coefficient times our constant, so it multiplies to negative 90 and adds to a negative 27. So automatically you may be thinking 9 times 10 multiplies to 90. We need 1 positive, 1 negative, but 9 plus negative 10 only gives us a negative 1. So we need our numbers a little bit further apart to have that difference of 27. When you multiply to a negative, you're really looking for the difference of the two numbers being the middle term. In this case, we're looking at 3 times negative 30, and that 3 plus negative 30 will give us our 27. So we rewrite this, keeping that coefficient of the negative. We keep our 9x squared. We split up that negative 27x as a positive 3x minus 30x, and we keep the minus 10. Once we've done that, inside we'll factor by grouping. The 9x squared and 3x have a common factor of 3x. I wanted to use brackets on that one. So dividing by 3x, we've got 3x plus 1. The second set of terms, we have a common factor of negative 10. Dividing that out, we get 3x plus 1. Inside the parentheses, we've got the common factor of 3x plus 1, so we'll factor that out. And we're left with 3x minus 10.